Welcome to Engineering Theory.
Hello friends, welcome to Engineering Theory, and today's topic is pneumatics and hydraulics. So basically the question starts from here: what is pneumatics and what is hydraulics? So basically these both are fluid based systems. Fluid based systems. Now what is it? Basically there are a lot of there's three kind of systems actually: electrical systems, hydraulic systems, and pneumatic systems, which is used to obtain a certain kind of work. You might have seen uh, excavators, or you might have seen air pressure brakes, or electric is the most common. So these are the systems which are used to get obtain certain kind of work. Pneumatic systems are the basically air-based systems, air-based systems which uses air as the transmission media. All right, these are fluid-based system which uses air as a transmission media, and hydraulics is the air fluid-based systems using fluid, especially oils, like as a transmission media. Okay, let's so now just see the simple difference between the electrical, hydraulics, and pneumatic systems on the basis of some few parameters like energy source, storage, distribution, cost, linear actuation, cautions, and transmission. So let's begin with transmission. First of all, this is a basic definition. Transmission uses mechanical components. All right, so like any systems like which is using mechanical components and the electricity to get the work out of it. So this is called electrical system. Hydraulics uses liquids. All right, as I already told you, that oils or water is generally not used because water is very corrosive, so it has not transmission properties is not so good. So oils are used, uses liquids, hydraulics, and using gases we obtain air, or nitrogen is also common. If it is not air, then it may have maybe nitrogen, but air is most common. Nitrogen is also common in advanced pneumatics. So let's uh, get the first point: energy source. These have AC source or DC source. This very common to you, only known to you. Electrical motors, diesel generators, and hydraulics. So energy source in electrical is AC DC supplier. In hydraulics is electrical motors or diesel generators. So these are the generators which run pumps or compressors, which is used to compress the fluids. Okay, in the same way it is pneumatics, electrical motors or generators, same way as that. Then storage we have. Storage means that uh, the place we can store the electricity, where place we can store the fluids, like that. So obviously we know that it is batteries where we store electricity. Limited because batteries are bulky, consume space, heavy. In hydraulics also limited because it's difficult to store fluid. It's not like tank. In hydraulics we have a tank from where we get the fluid, but in storage capacity is accumulators. These are known as accumulators, where we store within the system. Tank is basically the outside of the system. All right, it has very good reserve storage as a reservoir, because air comes from atmosphere, compressor compresses it and stores in the reservoir, and reservoir provides the fluid, provides the air to the system, so it has a very good storage capacity. Distribution system, we know that electricity has very good distribution because of flow of electrons. So distribution system is excellent in electrical because of flow of electrons, because the flow of electrons is very smooth. In hydraulics we have let's make a difference with lines from there, so that it doesn't look messy. All right. So in hydraulic systems we have limited distribution because of internal viscosity. This is very important property. Like friction in solids, we have viscosity in fluids. Most of you friends will be familiar with viscosity. If you know or not, so go in the fluid mechanics subject. So due to viscosity, distribution is not so good because pressure losses are there, velocity losses are there. All right, so in pneumatics it's good, distribution is good because it's only air and air has a good flowability. Cost. Cost is very simple. Lowest in electrical, you might have visited, if you have visited a electrical shop, you know that it's very low cost. All right, highest in hydraulics. Why? Because the hydraulics are not so safe, so we need to design such a pipes, such a ducts that which are highly safe and we can use it within the permissible limits, you know, having the considering the factor of safety. So highest in the hydraulics, medium in the pneumatics, not as less cheaper than electrical but not as costly than hydraulics. Lean actuators. Actuators means that where we obtain the motion. So in electrical system we have solenoids, you know, when we change the polarity of current, the direction of solenoid changes. Solenoid moves forward and backwards like this. In both the hydraulics and pneumatics, cylinders are the actuators, but in hydraulics, cylinders are subjected to high forces. In pneumatics, they are medium forces. All right. So this is another categorization. Cautions. So every time we use a system, all right, we need to be very cautious about it. So danger of electrical shocks, very common in electricals. Leakage danger, all right, if fluids leak, fluid is oil, so it is flammable. So if fluid leaks, it can catch fire, so fire hazards is there, which can be disastrous. Okay, if there is a leakage and hydraulics, which can be disastrous. Pneumatics, it is of noise, you know, you might have opened the valve of a cycle tube, so air comes out from it, very noisy. All right, noisily. So noise is the problem, but at higher magnitude it can be very dangerous also. So noise is a caution. All right, so let's come to the valves. So valves. What are valves? Basically, valves are the devices which use to control and direct. Very important words. So without these, using these words, you are not getting, you are not going to get marks in the exams. Used to control and direct flow of fluids from pump or compressor to the various loading devices. All right, to control that how much quantity we need, direct where we need actually. All right, so to control and direct the flow of fluids from the pump or compressors. Pump in case of hydraulics. All right, so hydraulics, and compressors in case of pneumatics. To various load devices. Broad classification. All right, so broad means less words. So broad classification, there are two types of infinite valves: infinite position and finite position. All right, so infinite position valves, basically these are like regulators of fan through which we can control the speed of fan. So if we want to run a fan at number 1, we can. If we number 5, we can. So these are the allow any position between fully open or fully closed. All right, so like a pressure regulator, if you don't know what is pressure regulating valve, we'll see. Pressure relief valves, which can be open, which can be closed, but which can be at any position, intermediate position between the two. Finite position are analogous to switches. All right, either it is shut, either it is open. So either it is off position or on position, like a direction control valve, DCV. Now, what is the direction control valve? Valves used to control the direction of the fluid. All right, these are the direction control valves. So other classification, let's come to this. So that's in brief classification of on the basis of construction and on the basis of function. Construction, there are two types of construction. All right, sitting valve, valve which is sit on the seat, all right, which sits on the seat and opens when there's a specific pressure is there, all right. So like poppet valve we have, which is most common, all right, most common and universally used in case of sitting valves. But spool valves are different. These are don't sit in at seats, but they are rotary or sliding. So these are the most common in industries, all right. So poppet valves are most common in its category, but these are the most common, all right. Rotary or sliding valve. We'll learn these valves in detail. Function. So on the basis of function, we have pressure control, flow control, and sorry for this smudge. This is direction control. All right. So this is direction control valve. Here it was DC valve. So pressure control valve function. This is function valve which is controlling the pressure is called pressure control valve. Valve which is controlling the flow, it's flow control. Controlling the direction is direction control, and there is a huge theory on these kind of valves. So these are important. These are equally important, but we will study these type of valves in detail. All right. So these are the basis on the basis of function, pressure control, flow control, and direction control. On the basis of construction, we have sitting or spool. Broadly, we have infinite position valve and finite position valve. So that's enough in this lecture. We'll study these valves in detail in the other lectures. Thank you, and hopefully you like it and understand it.